All right, let's go ahead and get started. I do want to welcome you to the fourth installment of Unit 0. We're going to be talking about density in this unit and or this part of the unit. And what do we mean by density? Well, density I think is fairly intuitive for most of us. If we have a cotton ball, we know that there's not very much mass in a volume of cotton. In fact, even if the cotton ball is quite large, there's just not very much mass per unit volume, as opposed to, say, a ball bearing or a rock. Those are going to have a lot of matter in a specific amount of volume. So we're going to use this formula right here. Density is equal to mass divided by volume. Density is equal to mass divided by volume. So I'll abbreviate that with the letters D, M, and V, just like that. Density is equal to mass divided by volume. And I need to be able to mathematically manipulate that, or algebraically, I should say, manipulate that to get at mass and volume as well. If I want mass, what I'm going to do is I'm going to bring volume up. So we're going to say density. That little dot right there indicates multiplication. So density times volume is equal to the mass. Or if I want volume, I pull the volume up, pull the V up, pull the D down. So volume is equal to mass divided by density, just like that. So in either situation, mass or volume, I need to be able to mathematically manipulate those in order to get at what it is that I'm interested in. So there's another way actually of doing this, and let me just briefly teach you how to arrive at these same things. Let's just say I'm interested in density. I'm going to use this triangle right here, and notice I've got an M on top, a D on the lower left-hand corner, and a V on the lower right-hand side. And what I'm going to do is I'm going to cover up what I'm interested in. So for example, if I'm interested in density, I'll just cover that up. You can use your finger, or I'll use a highlighter to cover that up. And so density then is equal to, well, what's left? Mass on top, volume on bottom. So density is equal to mass divided by volume. Density is equal to mass divided by volume. And of course, that's the basic formula, right? Density is equal to mass divided by volume. But what if I'm interested in mass? Well, in this case, what I'll do is I will highlight mass, just like that, or put your finger over it on your scratch paper. If I'm interested in mass, I'm going to look to see what's left. We have density times volume, right? Density times volume. And that's exactly what I've arrived at algebraically. Mass is equal to density times volume. So I could have done it either way. So let's now talk a little bit about volume. How do I arrive at volume using the triangle method? I'll just cross over the volume. When I do, what's left? We have mass divided by density. Mass divided by density. Well, that's exactly what I've got here. Mass on top, density on the bottom. So, again, it's entirely up to you. If you prefer the triangle method, that's fine. If you feel more comfortable doing it algebraically, just the important thing is that you have a system that you can use and manipulate the density formula. So again, density is equal to mass divided by volume is the basic formula. But if I want mass, density times volume. If I want volume, that's mass divided by density. Okay, so let's try a few problems. So here we go. Problem number 1 says this. It says if a block has a mass of 18 grams and a volume of 9 cubic centimeters, what is its density? Well, I know the basic formula. Its density is equal to mass divided by the volume. And I've been given the mass. 18 grams is my mass. All right, 18 grams is the mass. And I'm going to divide that by the volume. That's 9 centimeters cubed. All right. Certainly don't need a calculator here. 18 divided by 9 is 2. And so my answer would be 2 grams per cubic centimeter, just like that. That's it. That's my density. Density is in mass per unit volume, so I'm getting 2 grams per cubic centimeter, just like that. Let's go on to the second problem. We have the density of an object is 2.7 grams per milliliter, and the volume of that object is 150 milliliters. Find its mass. I'll underline what I'm looking for. I'm looking for mass. So let's start with the basic formula. We have density is equal to mass divided by volume. Now remember, I need to be able to manipulate that to get at what I'm looking for. I'm looking for mass. So I'll pull the volume up. So we have density times volume then is equal to mass, just like that. Density times volume is equal to mass. So let's plug in. They're telling me the density is 2.7 grams per milliliter, just like that, and that the volume is this. The volume is 150 milliliters. So I'm going to multiply that by 150 ml, and when I do, notice milliliters and milliliters on the lower, on the bottom and on the top are going to cancel, leaving me with grams, which is a unit of mass, which is exactly what I want. So now it's just a matter of plugging those numbers in the calculator. The 2.7 and the 150 are both on top, so I'll just say 2.7 times 150. 150, 150, and here's the number that I get. I get 405, 405, and that is grams. By the way, be sure and follow me on the calculator with all of these calculations that I do, because you don't want to just write these down, because on quizzes and exams you won't be used to using your calculator. So make sure that you're following me on your calculator. All right, so here we go. Number 3. Number 3 says the mass of a 5.00 cubic centimeter volume has a sample is 11 grams. We're looking for the density. Simple enough. Density is equal to mass divided by volume. The mass, I'm told, is 11 grams. How about the volume? Simple. 5.00 cubic centimeters, just like that. My answer is going to be in grams per centimeters cubed. That's the volume. And you probably can do this in your head, but I'll use a calculator. We've got 11 divided by 5.00, and we get 2.2. So 2.2 grams per cubic centimeter then would be the density of this object. All right? All right, let's move on to something a little bit more involved, and that is a situation in which I have to experimentally determine what the volume of an object is. So it says a rock is placed in an electronic balance and is shown to have a mass of 9.45 grams. So that, of course, is my mass. The rock is then dropped into a graduated cylinder shown below. And the question is, what is the density of the rock in question? What's the density? Well, remember that density is equal to mass per unit volume, right? Density is mass divided by volume. Well, the mass is given to me directly. It's 90, I should say, 0.45 grams, just like that. But what's the volume? Well, they're not telling me the volume. They're showing me the volume. They're saying initially I had a volume of just plain water, the graduated cylinder, of 30 milliliters. That might be a little bit difficult to see, but take my word for it. It's 30 milliliters, right? But when I drop the rock into the graduated cylinder, here's the rock down here. You can see down here that the rock displaces a certain amount of water. In fact, we went from 30 to 40. That's a difference of 10 milliliters. That means the rock must have displaced 10 milliliters. So the volume of the rock then, and by the way, this is a common technique for determining the volume of an irregularly shaped object like a rock, is 10 milliliters, right? So we have 90.45 grams per 10 milliliters. Folks, you don't have to use a calculator for this one. When you divide by 10, you move the decimal place over one time to the left, and we get this number, 9.045 grams per milliliter, and that's the density of that rock, okay? That's the density of the rock in question. Good. All right, let's go on to number 5. All right, here we go. It says if the actual density of water is 1 gram per milliliter, 1.00 grams per milliliter, and by the way, it is. The actual density of pure water is 1.00 grams per milliliter. And a chemistry student found the density of the water, doing some kind of an experiment, to be 0.84 grams per milliliter. What is the percent error? Okay, so we're back to a concept that we talked about in the last video, and that is percent error. So remember that percent error, if you recall, was equal to the value accepted minus the value experimental divided by the value accepted times 100, just like that. Well, what is the accepted value? We're told that it's 1.00 grams per milliliter. I'll leave the units off. minus the experimental value. So the individual who is doing this experiment got this number, 0.84, and we'll divide that by the accepted value again. So 1.00 times 100, just like that. So on the calculator, we're going to say 1.00 minus 0.84. I'm getting 0.16. I'll divide that by 1. Of course, that's 0.16. Then multiply that by 100, and we get this number, 16%. And that's our experimental error in this density problem. That'll do it for number 5, and that'll do it for this section of our notes. I'll see you in the next one. Thanks. Bye-bye.